What's good, everybody? Today we're gonna be reacting to world's biggest flashlight. Let's get into it.
This is the Immelin MS-18, the world's brightest flashlight that you can buy. And this is our flashlight.
Oh yeah, and this video is made by the Hacksmith.
This video is sponsored by KiwiCo, the fun and easiest way to learn how to make projects at home by yourself. A few weeks ago, we had a major power outage. Lights were out for a while. A long while. And if you follow our Instagram, which you should by the way, you might have seen a post of the entire team just sitting around in the dark. What do people normally do when lights go out? Light some candles and search for the flashlight. But we couldn't find ours, so we set out to make sure that never happens again. And to do that, we brought in Chris. Chris is an expert in all things LED and light optics. Chris, how many LEDs are in the world's brightest flashlight?
About 18.
And how many LEDs does DigiKey have in stock?
Check. 300.
Let's do that.
This is the Immelin MS-18. It is currently the world's brightest flashlight. It's so bright and so hot that you can only keep it on its brightest setting for so long. It's actually too hot to handle, much like myself. The best part about it, it's available on Amazon for only $800. The source of all this crazy power is the 18 Cree LEDs that provide this flashlight with 100,000 lumen output. 18 is a good start, but to make our flashlight, I've gone ahead and ordered 300 of these suckers. Just for reference, this is the current amount of LEDs in the world's most powerful flashlight, and this is the number of LEDs in our flashlight. 300 LEDs means I'm going to need to design a custom PCB to hold the diodes and get rid of any excess heat. Let's hop into Altium Designer, the industry standard for PCB design. You can download Altium Designer and try it for free at altium.com/yt/thehacksmith. You can view these custom PCBs on Altium Viewer. So I have 300 LEDs total, and I can fit about 6 LEDs per board. So that means I need, James, just ordered 50 PCBs.
50?
Yep. How am I going to get power to the 50 boards that I just bought? Well, LEDs are constant current devices, meaning the voltage can vary across them. The longer the LEDs stay connected to a depleting battery source, the dimmer they're going to get. So, how do we fix this problem? Well, in between the battery and the LEDs, we put a constant current LED driver. Imagine a lemon. When the battery is full, we only have to squeeze it a little bit to get some juice out of it. So as the battery begins to drain, we need to squeeze it even harder to get the same amount of juice out. So in this example, my hand was the constant current LED driver. It applied varying pressure to get the same amount of juice out. You know what they say, when life gives you lemons, make the world's most powerful flashlight.
With Stadia, you can play the biggest games in all their glory.
Hacksmith knows how to tie his own shoes, so we set out to design a pair of self-lacing shoes for back.
To sum it up, we have 300 LEDs. They are split between 50 boards. Those 50 boards go to 50 constant current drivers. Those 50 drivers, they are all powered by one battery. Make sense? Good. How about a bunch of lemons?
What?
Don't worry about it.
I love engineering, but it can be kind of hard to learn by yourself, and it's not easy to know where to start. That's why I love KiwiCo. KiwiCo helps inspire kids to see themselves as makers, engineering and creating their own innovative designs and outcomes. They provide these awesome monthly crates designed by experts that include all the supplies and instructions to build projects project from start to finish. It's a fantastic resource for learning at home. The included instructions and magazines have tons of extra content to take learning up a notch. Click the link in the description below and visit kiwicode.com/hacksmith50 and use my offer code hacksmith50 for 50% off your first monthly crate. Big thank you to KiwiCo for sponsoring this video.
When you add 300 LEDs in a tight space, things are going to get hot fast, and that's a problem. Traditionally, we just buy a heatsink, but everything we looked at online was just too small. So we're going to have to...
See, right now they're just ordinary stuff. You know, I don't feel like watching that. I want to see them make it. Alright. There you go.
I just have to do this 49 more times. Let's wire it up. As you can see, this is a lot of wires. Jimmy, why don't you walk us through what we're looking at here?
I don't know, man.
Jimmy. All right, I'll do it myself. A giant flashlight needs a giant switch. Let's go ahead and turn it on. You know what goes great with a giant switch? A giant button. Our flashlight is going to have 3 different modes: low, high, and turbo. And that's all going to be controlled by this little button right here. This is our control board PCB. Up here we have our voltage regulation into the board. Then we move down over here to our button inputs. Moving down, we have 3 more relays that control the low, high, and turbo mode for the LED itself. So look at all these wires. From the 3 relays, we have 3 bundles of wires. Those bundles of wires provide power to the LED drivers, which in turn provide power to the LEDs themselves. Finally, all those buttons, all those switches, all those screens, all those LED drivers come into this LED monstrosity. I guess all systems are go. Let's test it out. If you're interested on how this works, check out the circuit diagram on maker.io. To commemorate this glorious event, Jimmy and myself have put on GoPros to capture all of the action. Hi, Jimmy.
Hi, Chris.
But first, safety. Take a while. With that, I think we're ready. This little light of mine, I'm gonna let it shine.
This little light of mine, I'm gonna make it shine.
Jimmy,
Yes, Chris?
why isn't the flashlight working?
I don't know. Did you plug in the batteries?
Jimmy, this is an amateur hour, Jimmy. Did you check everything?
I checked every single one of them.
You checked the
I
LEDs?
swear. Yes.
Check the drivers?
Yes.
You checked the fuses?
Absolutely. Wait.
Oh,
wanna check the
Jimmy,
fuses?
Jimmy.
No.
Jimmy,
That was your responsibility.
Jimmy. All right.
Okay.
Jimmy, turn the light on. I can't see a thing.
Turn on the light.
That joint's actually that bright.
So, that actually worked really well. But as you can see, light just kind of went everywhere. And traditionally speaking, flashlights have a much more focused beam. So, let's see what we can do about that. You might have seen Grandma or Grandpa using one of these things. It's called a Fresnel reading magnifier. It allows you to focus on a certain area of text, kind of like a magnifying glass. If we take a light source and apply it to the other side of the lens, we can actually focus light into a point. You know, kind of like that kid at recess who used to burn ants. We can take this principle and apply it to our flashlight. We're going to need something a little bigger. Oh my God. Well, the bag's on fire. Man, that is some black smoke. Oh, the golf ball's on fire. Golf ball's really on fire. have our big lens, we need to ensure that all of the light from here makes its way into here. We can start off by actually getting a smaller lens and putting them on each of these individual LEDs to ensure the light is as collimated as possible going into the bigger lens over there. But what about this gap in between? You're going to need a way to actually keep the light in a tunnel. So I've gone ahead and sourced a fancy reflector, also known as a common trash can, to go in between. Let's just get rid of this though. We're gonna saw the bottom off and coat the entire inside with this reflective material to make sure it doesn't catch fire. What about all these electronics? Where are they gonna go? And how are we gonna hold it? Well, I've gone ahead and sourced something that I think we can fit everything into. So now all that's left is to put it together and give it a coat of paint. James, one golf ball, one garbage can, and one pair of oven mitts.
I thought you were really a flashlight.
Oh, I am. The giant LED array has been mounted to this concrete footing. I've taken all the wires and pulled them through so you can see them right here. A little bit of a mess, but piece by piece it's coming together. This is like the last 5%, so let's say 95% done. It's gonna work. Look at that. It's a flashlight, it's gotta be clean, you know? Also, this was the garbage can, so there's that. Jimmy, I need you to go dry the garbage can.
Right now?
Yeah, like right now.
Seriously?
Yeah, man. Is it dry yet, Jimmy? Oh, VHB. Gonna use it all. Don't tell Dave.
That is fire. Like the design is fire. I like the design of it.
I be the boss, give me the sauce, baby. I knock it toss, baby. Give me the sauce, baby. Now when I dip you, don't even trip, boo.
Choose 4, 5, or 6 fingers in any of our famous sauces with the chicken finger plate. Only at Hacksmith. Order ahead, drive through, or get it delivered.
Whoa, what are you doing? It's a flashlight, not a battering ram.
Come on, man. It's a Hacksmith video. It's what I do. All right, this flashlight looks incredible. Chris did a fantastic job. But how does it stack up to the competition? Let's find out. Lights.
So over here we got your standard rinky-dink over-the-counter flashlight. We'll see how it does. Not great.
All right, let's try the Immelin MS-18. This is the world's brightest production flashlight available. Woo!
Pretty bright.
It's pretty bright. Oh, there goes the fan.
Think we can do better though?
3, 2, 1. Ah! You can't see the sign LEDs anymore.
Oh God.
Lights! Alright, so that certainly looks impressive, but maybe we could measure the light output in a more scientific way. This is called a Crookes radiometer, and it actually measures light radiation. Let's see what happens when we put this in front of each flashlight. Alright, starting with the rinky-dink flashlight, let's see what happens. No, it's
It's moving. Oh yeah, one rotation every hour.
Not that slow.
Let's try bringing it a little bit closer.
There we go.
Solar power right there.
Slowly spinning. All right, let's see what the Emerald 18 can do. All right, world's brightest flashlight. Let's see what happens. Uh-oh. Oh,
It's spinning.
oh. It's spinning real fast. Let's try our flashlight. You can't see anything. All right, we've only got 7 seconds before this baby overheats. Let's do it. 1, 2, 3, 4, 5, 6, 7. Woo! Look how fast it's spinning.
Holy crap!
It broke it. Oh my God. How did light fold something?
What have we done? What have we created?
Look at that. All right, that was pretty impressive, but we need to give this bad boy some room to breathe.
You know how big a football field is, right? Let's start with the rinky-dink flashlight.
Very good. Is it on?
Yeah, it is.
I can barely see it. All right, let's try the Emerald MS-18, the world's brightest flashlight. Woo! That's pretty bright. Well, let's see how ours does.
It's so bright. Jeez.
Remember Grandpa's reading lens from before? Well, here it is now. Let's see what happens. Oh, God. What do you think? High beams?
High beams.
All right, I think we've made the world's brightest flashlight. And like a true Hacksmith project, this thing almost weighs as much as Stormbreaker. So good job. That is a requirement for our projects.
Oh, boy.
Great work, Chris.
Yeah, thanks. Thanks a lot. It was really fun. Remember to like, comment, and subscribe. Pew, pew. Pew, pew.
Alright, man. You seen it, man. That's it for the video, man. Make sure you like, comment, and subscribe. Just like he just said.